Good evening everyone. Today we are going to the daily Leetcode challenge of 8 February 2023. That is question number 45, jump game 2. We are given an array which is 0 base indexed and the length of the array is n, and we are initially positioned at num 0. We can move up to nums I plus j where j is less than nums I, and I plus j should also be less than whole length of the array, that is n. And we have to return number of jumps required to reach the last element, and the test case are generated such that we can reach that. That means there is no case possible in which we cannot reach the final index. That is, there is existing a solution and we can find that. So let's move on to the examples. In the first example, what they want us to say that if we are at this 2 index, that is 0 index, its value is 2. So we can move at most 2 steps. That is 1 is this or 2 is this. We can move to any of these and we have to reach this last index in minimum steps. So if we move to 3, then we have taken number of jump 1, and from 3 we can move at most 3 steps, so we can directly move to true. So there are total 2 jumps for this case. But if we have chosen the other way, that is from 2 we have moved to 1, then jump would be 1. Then from this one we can move another jump, that is 1, and then from this one then we can reach the last one, that is 1. So total jumps would have been 3. So minimum of these two is 2. That's why our answer is 2. So this is what we have to do. Please try to think of an approach and then come back to the video. The hint for this is we have to apply the greedy approach to cover the farthest distance in minimum jumps. We have to move farthest in minimum jumps. Please try to think and then come back to the video. So I hope you try doing this question on your own. Now let's move on to a bigger test case and see how it is working. Let's take the example 3, 4, 5, 3, 4, 1, 2, 7. Let's mark the indexes, that is 0, 1, 2, 3, 4, 5, 6, 7. For greedy approach, we need to have 3 variables. Our greed will be for the farthest distance. Initialize it with 0. We also need to get the jumps count, which we will return as our answer. And we need to have the current index, that where are we currently. Initialize it with 0. So starting from the 0 index, our I is currently here. We can move up to 3 steps. That is from 0 we can move here, we can move here, and we can move at most here. So farthest we can move up to 3. For that we have taken one jump, and we will initialize our current with the farthest for now. After that we will move our I to here. Now from 4 where can we move? We can move up to 1 step, that is 2. Is it more than 3? No, we won't do anything. Then we can move our I here. From 5 we can move another 5 steps, that will be 1, 2, 3, 4, 5. That is, we can reach up to 7th index. So yeah, we can do this. Then after that we can move our I to here, and from 3 we can move up to 1, 2, 3, that is 6. 6 is less than 7, so we won't update our farthest. And when our I reaches the current, we will increase our jump. So we can say that yeah, we are at the farthest currently, so we can increase our jump. So our jump will increase to 2. And after that when we move our I here, that is 4 plus 4 is 8, that is we are exceeding the overall length. So our answer would be this, minimum number of jumps is 2. So that is what you have to do. That is how you are applying greedy approach. You are greedy for the farthest distance by taking minimum jumps, and you are changing jumps only when you have covered the farthest distance possible from the current I index. And if you are getting a more farther distance, you are updating the farthest to get the optimal answer. Let's see it in code and see how it is working. So for the coding part, we will start with creating the variable, that is int farthest is equal to 0, jumps initialize with 0, which we will return, and current would be initialized with 0 as well. When we are finally done with our code, we will return the number of jumps we have taken. So as I told you, for greedy approach, we are doing it in O(n) complexity. We will start iterating by for int I is equal to 0, I less than nums dot size, we will iterate till the whole array, and I plus plus. See what we can do, we have to write nums I minus 1. Why? Because when you have reached the last index, there is no further way possible. So your code will break if you go for beyond that. So we are going up to second last element. That's why it is nums size minus 1. Now what we can do, as I told you, we will update our farthest to maximum of farthest. That is it maximum or the nums I plus I is maximum? We have to check. Whichever is maximum, we will move till there. And if our I is equal to current, when we have moved to the current, what we will do? We will update our current to farthest, and when we are updated our current to farthest, we will increase the number of jumps, that we have taken one jump. That is all you have to do, as I explained in the code. That is when we are done with the farthest and our eye reaches the current, that is the maximum jump it can do, we are increasing our jump and we are checking whether we have iterated the whole array or not. That is how we are getting the farthest jump. That is all the jump game is about. So yeah, it is running. Let's submit and check whether it is accepted or not. So yeah, it is accepted as well. So the time complexity is O of n and space complexity is constant space. I hope you liked the video. Please like, share and subscribe. Thank you so much for watching. Bye bye.